Okay, guys, this is part 2 of our periodic trends video in AP Chemistry, and we're going to start with electron affinity. Okay, and the definition of electron affinity is the ability to attract electrons. Okay, it's the attraction between an incoming electron in the nucleus, and it's a measure of the energy that is released when an electron is added to a gaseous atom. Okay, usually the sign on the energy is negative. Energy is usually released in this process. A more negative electron affinity corresponds to a greater attraction for an electron. And the trend goes exactly in the same direction as ionization energy and electronegativity. Now, electronegativity is the ability of an atom that's in a molecule to attract shared electrons to itself. Okay, it's used in bonding. It's a measure of the ability to share electrons. Differences in electronegativity will help us define the type of bond that forms between two atoms. If you have a greater change in electronegativity, the more polar the bond, which means the more unevenly shared the electrons. And again, electronegativity increases the same direction that ionization energy does, as well as electron affinity. Up from the bottom to the top, left to right. Okay, so let's just conclude this video with some things to remember. Okay, so we've talked about atomic radius, ionization energy, electron affinity, and electronegativity. Okay, you need to be able to define all of these trends and why they occur. Okay, if you go up and down a group or a column, remember the valence electrons are farther away from the nucleus as you go down, and there are more inner or core electrons shielding them from the pool of the nucleus. You go across a row, really all the electrons being added are at the same energy level, but you're adding in a proton each time you move to the right. Okay, and therefore the nuclear charge or the Coulombic forces is increased. Okay, sometimes anomalies do happen, and you've got to see how the orbitals are filling. Are there unpaired electrons? Are you adding a second electrons to an orbital? Okay, so why don't you pause this video and use principles of atomic structure to explain the following. Okay, so now that you've finished that, let's talk about the reasons, the explanations for the following. Okay, potassium has a lower first ionization energy than lithium. Okay, well, potassium is lower in group 1 alkali metals. Okay, it is lower in the group, therefore it has more energy levels. Okay, it also has more electron shielding, which shields the valence electron from the nuclear charge. And therefore, it's easier to pull a valence electron, the first valence electron, off of potassium than lithium. That's where the valence electron is closer to the nucleus. Okay, sodium and magnesium. Sodium and magnesium are both period 3 elements. Okay, and however, sodium has a 11 count proton, has 11 protons, whereas magnesium has 12 protons. Okay. Therefore, magnesium has a stronger nuclear force, a stronger Coulombic force holding the valence electron on than sodium. Okay. And then the last problem, explain the difference between calcium and potassium in regard to their first and second ionization energies. Well, if you write out the electron configuration for calcium, okay, it is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. if you write it out for potassium, it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, so you can see for potassium, when you get rid of the first ionization energy and you jump to the second, okay, when you jump to the second, you see a huge difference. And that is because you're changing energy level. You're going from 4 to 3. For calcium, you can see that the first ionization energy, you're taking off one of the 4s, and then the second ionization energy, although higher, is not drastically higher because you are still within the same energy level. Okay, and that's really it for this last part 2 video. I hope you learned the definition of electron affinity. I hope you learned electronegativity's trend, and I hope you learned some problem solving skills in solving periodic trend problems.